In chapter 4.3, we start with partial derivatives. So the partial derivative of a function x, so in this case we're dealing with just two variables, an x and a y, so the function f is going to have variables x, y, and again this can be extrapolated to x, y, z, 4 variables, 5 variables, and so forth. So the partial derivative of f with respect to x can be written like this, df dx, so the derivative of the function f with respect to x, or this f with a subscript x, indicating we're taking the derivative of the x portion of it. So here's the limit that you know and maybe love from Calculus 1. It's going to look very similar to that. The limit as h approaches 0 of your function plus an h minus the original function over h. I'm not expecting you to use the definition. Again, you probably had that for one small section of calculus, but after that you took the derivative from all of the other different methods. I'm not going to have you use this limit to solve anything, but effectively, when you're taking the derivative with respect to x only, you treat any other variable as if it's a constant. Similarly, if you're taking the derivative with respect to y, this derivative of the function with respect to y, we're only looking for y as the variable. Any other variable in there will be treated as a constant. So as an example, or it looks like I've got two here, our function is the letter z instead of f. You can use f if you want instead of z, that's fine. So you could literally write this f subscript x, which is equal to dz dx. I know the f looks weird, but that's proper notation, it's fine. All right, so we're going to take the derivative of this with respect to x only. So the derivative of x squared is just 2x. And the derivative of negative 3xy, again, we're treating the y as a constant. So this is just negative 3y, and then times 1, essentially. That's the derivative of x. And the derivative of y squared is 0, because that's a constant. So, in effect, this is 2x minus 3y, and that's it. If we wanted to take the derivative with respect to y, and the question doesn't ask for it, but I'm going to do it. So f of y is dz dy. Now we treat the x part as a constant. So this first part goes to 0. The next part is minus 3x, and our y, derivative of y is 1, and then x plus 2y, which would give us 2y minus 3x. And look, they're very similar given what we had here. All right, let me erase that, excuse me. So this next problem, we want to take the derivative with respect to x, and we are going to only look at the x part. So essentially this, I'm going to rewrite this and have this as cosine of 3y. That's all a constant. And then we just want the derivative of the next part, sine of 3x. So the derivative of sine of, this cosine is up front. Cosine of 3y, that's our constant. We pull that out. And now the derivative of cosine of 3x, excuse me, sine of 3x is going to be cosine of 3x times the chain rule part. And the chain rule would just be another 3. So you can put the 3 in front if you want, otherwise that's what we've got.